Hello, today we will see solid principles. Okay, so have you ever fixed one small bug in your Java code? And let's say, suppose how other features stopped working. This happens because of your bad design. And today we will discuss about how to avoid this using the solid principles in Java with real world and real time examples. Okay, so stay connected till the end and watch each and everything which we discuss here. So we will see first solid principle, that is single responsibility principle. We will see the problem first. Okay, so what is the problem here? Okay, so single responsibility principle, what it says that each class has only one reason to change. Dependencies are injected through the constructor. The code is more maintainable and testable. You can easily swap implementation, switch from text invoice to PDF invoice. This is one example we have done. So this is the tightly coupled class. Okay, this is order manager. Okay, and in this class, let's say you have written everything in this class. So this is tightly coupled, right? So you have written create order code also in this class. You have written save order flow code, save to the database. Okay, this code also you have written in this class. Then you have written sending the notification if the order is complete, then sending the notification to the customer, to the user. That code also you have written in this class. You have written in this class also sending the invoice, creating the invoice, everything, and place order, everything you written in the same class. So what will happen if one thing get break, then everything will get break, right? So let's say create order, or let's say you are depending on so let's say your order is created, and your database is also, uh, you are trying to save into database, but it got failed. Okay, then your system, everything will get failed here. Okay, so this is bad design, and everything you have put in the same class, that is also not a good thing. So low cohesion here. So low cohesion means class should have a high cohesion, and it should have a loosely coupled classes, but this is the tight coupling. So coupling is tight with this. So your class is doing n number of tasks at the same time. It's creating order, it's sending to database, in it's sending email notification, it's generating the invoices, it's placing the order. Everything the same class is doing. Okay, so it is tight coupled class, and this class must to be changed. Okay, so this is not following. Low cohesion means here it is not following the principle of single responsibility. So what single responsibility principle says that your class should have only one and one responsibility. So if it is order manager, so it should create only the order. So sending to the database should be have managed by different classes. Sending email notification should be managed by different classes. Sending invoices, creating invoices, generating invoices, and sending to the customer should be managed using different method, different classes. Placing order should be managed by different things. So this separation of the task is what needed, and that's what your single responsibility principle says. But here it is getting violated. Okay, so let's see how we can, add the solution for that. Okay, so here is the resolution for that. We created, say, let's say order service. This is one class, and we created different interfaces for different purposes. Let's say order repository interface we created for database purpose. This we created for database saving purpose. Then email service we created for sending email to customer. Email to customer saying that your order is successful. Okay, Then we create an invoice service to generate the invoice. Okay. In different formats like PDF, text, etc. Okay. So in the constructor, we are initializing everything. All interfaces we are initializing in constructor, and we have written this method place order. Okay. So once the order is placed, then we will send email to the customer, and then we will create the invoice. In this way, separation of the task is there for each and every interfaces. So we created this email interface, and in this interface only one method is there. So single responsibility principle we have achieved here. Okay. So in this email service, only email service is only sending email. Then invoice sending is only generating the invoice. Then order repository is only placing the order, which is dealing with database. Okay. So let's say we have sending the text invoice currently. So text invoice will implement your invoice service, and it will generate the invoice in text format. This is text format. Now let's say tomorrow I want to, generate invoice using PDF format. So PDF invoice is the class you will create, and which will implements a invoice service. So which will implement invoice service. So just implement the methods from it. Create invoice. So creating an invoice in PDF format, and your all logic of creating the invoice should go here. Okay. So this is the single responsibility principle. Here you have not touched any other things. Okay. So you are extending your logic. Okay. And your invoice service is responsible. It is having only single responsibility. Email service also, it is having sending email only responsibility. Okay. And how you are using that one? So you created one order service class, and you created here interface references. And in constructor, you are initializing those references. Those are final references. And in place order method, you are using those references. Perfect. So this is single responsibility principle. So let's check next principle, that is open close principle. If you open this, okay, open for extension, your class should be open for extension but closed for modification. So let's say, okay, so what does that mean? So same class should not be modified when you add a new payment methods. Create a payment strategy interface. If you see the problem here, this is the bad design, right? Okay. So here you created a process payment method, and you created the payment type. And let's say you have some payment methods like credit card payment, UPI payment, wallet payment. This is the payment. And let's say tomorrow you want to add cash on delivery payment. Okay. So what you will do? You need to modify the existing class. This existing class you are modifying. But what this rule says? This rule says it should be closed for modification and open for extension. You should extend it further, but you should not modify existing. But let's say I want to add cash on delivery payment. cash on delivery payment I want to add. So again, you need to modify this one. You need to write else payment type dot equals ignore case is COD. Okay, then you need to implement logic for processing cash on delivery payment. So you will write some instruction here, right? So our representative will come to your house, then they will hand over the parcel to you, and then you need to make the payment. Like that instruction, suppose you want to give, then or any other payment type you want to add, then also you need to modify this existing class. That is the bad design. Okay. So if existing classes need to be modified every time, you violate the open close principle. So this is the real world example. Okay. If you want to, if you want one another example, then there is electric switchboard. Okay. And that electric switchboard is closed for modification. And suppose you want any extra thing to implement that one, like fan. Suppose you want to add one fan. So what you will do, you will not your break your wall and change internal wiring and all. You just get a plug and put it there and get the connection from it and use for that fan. That's what you will use, right? So you will extend it further rather than modifying existing things. So here also in solution, if you see the solution of this one, okay, so we created we created this payment strategy as interface. It is having one pay method, and this is very generic method, and multiple like credit card payment is the class which will implement that payment strategy method, and it will pay using the credit card. Then wallet payment is another class which will implement your payment strategy method, and it will pay using the wallet. Then let's say uh, tomorrow your COD payment comes. Okay, COD payment comes and which implements payment strategy. Okay, so here you what you will do, you will pay using, you will add the instructions. Okay, when when the parcel will reach out to your home, then pay plus amount plus amount to the delivery agent. Something you will add, right? So it is not breaking any existing thing. Okay, credit card payment, how it is used. Okay, so credit card payment, cash on delivery payment, payment service. So you have not changed any payment service method, right? Payment strategy, just you are defining there, and make payment, pay method you are using, right? High level method. And whatever the services are there, those are implementing the payment strategy interface. That's why this is open for extension. Like wallet payment. So let's say tomorrow any new payment strategy comes. Then you can create a new class and implement this payment strategy method. So it is open for extension, but you are not modifying this payment strategy or this payment service. You are not modifying, right? No matter how many payment methods are there, you add this class, never change. Okay, this class will not change. Okay, that is the solution for that. That is open close principle for that, for you. Okay, so this is some example. Okay, So you need to check this example and all. Okay. So this is one sample example I have given. So each payment class does exactly one job, and very loose coupled and high cohesion you have achieved there. Okay. So let's say now third principle is Liskov substitution principle. We will see what is mean by that. Let's close everything. Okay. Go to this readme file and check. Objects should be replaceable with their subtypes without affecting the correctness of the program. So this is very high level, right? Let's break down this one. Means in very simple language, child should listen to their parent. Actual use case, I will tell you. Okay, let's say there is one COD payment is also supported. Let's say there is cash on delivery payment is also supported. Okay, so we have this payment related things, right? Here cash on delivery payment is also supported, but let's say this is your child and this is your parent, right? Payment strategy your parent. So what payment strategy is saying? Go there. It's saying just implement this pay method no matter what. Okay, but what your cash on delivery payment method is saying, hey, I don't support the, you are throwing an exception there. From pay method, suppose let's say you are throwing exception, throw new unsupported operation exception because I don't support the online payments and all. That's what if your cash on delivery payment method is saying, then it is very bad design. So you should say, you should give some message from there, right? If you go here, cash on delivery payment, and rather you should say your order is placed, buddy, and you can pay this amount when parcel reaches to your home by a delivery agent. This message you should give, right? So this is very simple. Like whatever the values your parent give to you, whatever. So why it is good? It does not break the parent contract, right? What your parent is saying, implement the pay method. Okay, so you are implementing the pay method here. So it gives a valid payment behavior and it works flawlessly whether program, whatever the payment strategy is used, cash on delivery, wallet, whatever is used, right? It will work flawlessly. So this is the third principle, Liskov substitution principle means listen what your parent is saying and don't, argue with your parent in simple word. Okay, and don't break the contract of the parent. Okay, this is third principle. Let's move to the fourth principle. Just close everything and move to fourth principle. What fourth principle is saying? Client should not be forced to depend on method they don't use. Sometimes we see, okay, let's see the problem. What is here? Okay, see, let's say you are sending the notification after the product is bought, right? So you are sending the notification to the client, hey, thank you for buying this product, and your product will reach out to you in this many days. Suppose this is your business want, whatever. Okay, sending the message to the client. But let's say this is what sending the email notification is what supported currently. Sending email notification is what supported currently, but you have different ways for communicating to the user, like sending SMS, by sending WhatsApp messages, by sending any push notifications. All these means are there, but your company, your business is only using email, but you have mentioned all these strategies, all these methods in your single interface, so which is violating your interface segregation principle. What interface segregation principle says that, let's say your company only sends the email once the order is complete, and which is not supporting SMS, WhatsApp, push notification. So you should design an interface which deal with sending the emails only. Why you are writing your SMS, WhatsApp, everything in single interface? That violates the principle. So in short, split the large interface into smaller one focused interfaces. Okay. So let's move to the solution to the fourth problem, that is interface segregation principle. What it is says that, okay, email notification system. Okay, implements I email notification. So you created different interface. I email notification you created, send email method you return, I push notification interface you created. So here also suppose you want send email, right? Push notification. Here you can write void send push notification. Only single responsibility also you have given this one, right? So it also follows the single responsibility pattern also. Okay, so here you created ISMS. So here you will write method void send SMS. Okay, and in WhatsApp notification you will write method something like void send WhatsApp notification. Perfect. And email notification system which your company currently using, right? So here you will implement your sending email logic. That's what. This will, this currently you are not implementing anywhere, right? So leave it as it is. If you go to our original system, right? So here what you was doing in email, your business is wanting to send email, so you are writing that logic here. But for any other system, how you are doing, you are throwing an exception there, unsupported operation exception, SMS is not supported, WhatsApp is not supported, your push notification are not supported. In this way, this is very bad design and you should avoid this one. That's what uh, interface segregation principle says. Okay, so here are some theoretical things are written here. Simple meaning, don't create giant interfaces, right? Don't create a very big interfaces. Create small specific interfaces. A class should implement only what it need, not okay, what it need, that should only class interface, need not to be there more. Okay, means what it is not needed, then our class should not implement that one. So real time problem, real world software scenario is there. So you are building order notification system. Notification include email, SMS, WhatsApp, push notification. That's what we saw just now. So your company want, only sending email notification, but you are ending up with writing all everything inside a giant interface. This you created a giant interface which is doing everything. So that is not a good thing. So how you are implementing, only sending email you are implementing, and for other you are throwing exception, right? Unsupported operation exception. So that's it, that is not good thing. So here how you will provide the solution for that, just create a different interfaces with what it is actually doing. Let's say email notification, it is only sending the email. Push notification, it is sending push notification. SMS, it is only sending SMS on mobile. And WhatsApp notification, it is sending on WhatsApp. And create a concrete classes that should implement your individual interfaces, and that's it. So this is your fourth principle, that is interface segregation principle, means don't add everything inside one interface. And your fifth principle is dependency inversion principle. Let's say what it is doing. High level module should not be depend on low level modules. Okay, both should be depend on abstraction. Means simple means your main business logic should depend on interfaces, not the concrete classes. Avoid new keyword inside business logic, inject dependencies instead. If we open the problem, what is the problem here? Okay, here you created payment service. This payment service is high level thing, right? And this high level thing is now depend on your low level thing. Low level thing is what? Credit card payment. But payment service should not be bother about which payment service you are using, right? If you are using credit card, you are using debit card, you are using master card, you are using wallet card, or you are using cash on delivery, payment service should not be bother about all those things. Rather, payment service should know only high level things, but it is low level things, right? Here you are creating this one, then you are creating, let's say, another object, private credit card payment you return, right? Then wallet payment, let's say you are writing wallet payment equal to new wallet payment you are writing. So this is not good thing, right? You are creating the object with new keyword. What it's saying, let's say in same example, payment service, assume your business logic directly create the object. Here object is directly getting created, right? So what is the wrong here? High level class is payment service. This payment service is very high level class. Okay, it is depend on low level class credit card payment. So this is very low level card, right? So credit card, wallet. So this is a mine, granular level things. So this should not know which thing you are using for payment service. It just want to get the payment done. Okay. Hmm? Not testable, cannot mock dependencies. Suppose you want to mock any dependencies or something. So that is also very much problematic, right? Because you are here creating directly objects. So violate both principles. Okay, dependency, inversion principle, it is violating. Okay, open close principle, it is violating. Okay, so and it is tightly coupled to difficult to extend, right? It is very tightly coupled, right? So here we are creating directly object, but why not interfaces? Okay, so let's say how we can solve this problem. Okay, so how we can solve this problem is payment strategy is one interface. Let's say we created the pay method there. Okay, business logic depend on payment strategy. Abstraction, this is abstraction. It is not concrete classes. And let's say credit card payment is there. So this will implement your payment strategy interface. Okay, and you are making credit card payment. Then and let's say now payment service, how it is using that one. Okay, so it is using payment strategy as interface. So if we go inside payment strategy, it is interface. So it is not creating object. Okay, it is not creating a object, rather it is creating the reference to this main interface. So in payment service, you are saying I am designing a strategy to make the payment. Okay, and you are writing very high level details here. Make the payment. So whichever method you want to make the payment, credit card payment, debit card payment, your wallet payment, your cash on delivery. Suppose you want to give anything, whatever you want to give that one, but make sure you buy this product, right? Amazon, that's what. Any other, online selling platform, what they want, e-commerce application, what they want, right? They just want to sell the product. They don't want to bother about which payment strategy you are using. That's what this service is doing. Okay, so payment service no longer create the object. See, here object is not created, right? And it is interface. We cannot create the object of interface. So how we are doing that one? So we are creating the reference object of this interface, and in constructor of this class, we are assigning that one, and you are making the payment. So how it is going to use? Okay, so let's say we created object here payment service, and here we are saying in constructor we are making credit card payment. Here we created the payment service object. Here we are saying making UPI payment, and whatever the payment is there, we are making that payment. Okay, and this class runs perfectly fine, and it follows dependency inversion principle. Okay, so real world analogy, super easy. Imagine you are buying the mobile charger, right? So you don't care which company brand is there, who is making that charger, but you are only care about whether it is support the USB port or not. So your phone you can get, your charger you can get, and you can just charge. Okay, so that's what. Okay, USB standard it is having or not, that is nothing but your interface. Okay, so you are not bothered about who created that one, how it is getting created. Those minor level details you don't want to know, right? That's what this dependency inversion principle says. Phone depend on abstraction. Abstraction is nothing but your interfaces. Interface is nothing but your whatever the exact use of that one. Okay, charging the phone. That's what you needed, right? USB charger you want in that your phone, and your USB charger should support that one for charging. That's what. How it is implemented, who made that charger, all this minor level concrete implementation details you don't need, right? So that's what dependency inversion principle says. Okay. So what are the benefits of the dependency inversion principle? Loose coupling. So high level code is not tied with low level classes. So what is the high level class here? So these are payment service, payment strategy. These are high level classes, right? They don't bother about which payment strategy you are using. Okay. So easy to switch implementation, whatever implementation, suppose you want to switch, right? Suppose today you want to credit card payment, tomorrow you want like online payment, suppose tomorrow you want to use debit card payment, then you are very much free to use that one. So this is a brief idea about a solid principles. It is used widely and asked widely question in any Java interview. So please subscribe to this channel and like and share and comment. Okay, thank you so much.